Welcome to Curium. As part of Structure 2.2.5, you are required to be able to deduce if a bond is polar based on electronegativity values and to represent bond dipoles with either partial charges or vectors. Note that the electronegativity values may be either quoted for you in the question, or you can refer to them in Table 9 of the IB data booklet. There are some key concepts which it will be helpful for you to understand before you begin. What is a covalent bond? What is a nuclear charge? What is electronegativity? And what is an ion? Note that the definition for a covalent bond and for electronegativity can be asked in paper 2. Let's imagine a molecule which is composed of two fluorines bonded together. Those fluorines share one pair of electrons in a single covalent bond. What holds those electrons in place is the fact that they are attracted to each fluorine's nuclei. As a result of this, that electron pair will be found, on average, approximately halfway between those two atoms. That's because there is nothing which would attract them permanently to one side or to the other. This is an example of a non-polar bond. The measure of that attraction to the nuclei is called electronegativity. This is simply the ability of an atom to attract a covalently bonded pair of electrons. If you have a more electronegative element, that means that it will have a greater attraction for those electrons and pull them closer. If you have a less electronegative element, that means there will be less attraction for the electrons, and so it will not pull those electrons as close. You can find the values for electronegativity in Table 9 of the data booklet. They're the value underneath the symbol for each element. A polar bond is different to a non-polar bond, and it results from having two elements with different electronegativity values. It means that the electrons which they share are not found in the middle any longer. They will be found closer to one element than the other. So the element which has the electrons more closely located to it becomes partially negative, while the element with the electrons which are further away from it becomes partially positive. One quick tip before we begin. In different sources online, you may see small electronegativity differences being quoted as non-polar bonds. For example, an electronegativity difference between two atoms of between 0.1 and 0.4 being quoted as non-polar. IB does not agree with this. They will only consider a bond non-polar if the electronegativity difference is 0.0. The only exception that they consider is the carbon-hydrogen bond, which they also consider non-polar. So something with a very slight electronegativity difference is considered to be slightly polar or weakly polar, but not non-polar. An example of an easy paper 1 question: which two atoms form the most polar bond? Your approach when doing this should be to remember the trend for that as you go up diagonally, the electronegativity increases. Then you try to find pairs of atoms which are far apart, not so far that they would result in an ionic bond. An example of an easy paper 2 question. You were told the molecule is pH3, and the first part of this question actually required you to draw a Lewis diagram for pH3. Once you have that drawn, you then look at the individual phosphorus to hydrogen bond and check to see if there's any electronegativity difference between them. You would find that they both have a value of 2.2, and so they have the same electronegativity, meaning that the bond is considered non-polar. Both of these questions would be considered easy. An example of medium difficulty paper 1 questions. Question number 3 gives you a number of bonds within molecules. Your first step would be to draw each of these molecules and identify what is being bonded, and then to look at the electronegativity differences between the bonding atoms. The larger the difference, the more polar the bond. Similarly for question 4, every one of the halogens is bonded to a hydrogen. That means the only variable which is causing a difference in polarity is the halogen. If you remember the trend for electronegativity increases as you go up the group, fluorine is the most electronegative. That results in the biggest dipole being created within that bond. A medium paper 2 question would require you to do something similar as the easy level, where this time you have to compare the polarities. So it's not just a simple statement of how if the bond is polar or not. Instead, you would need to make a comparative statement between the two things. Remember that when you were asked to compare two things, you should refer to both of them in your answer. So for example, CH is less polar than NH, or NH is more polar than CH. or if you make a summary statement that the difference in their electronegativity is greater for NH than CH.